Let's start with the second law now. So first, let's recall first law. First law deals with what, guys? First law deals with energy conservation. Energy conservation. This is the most simplest form that we can put the first law in, right? Then the second law deals with direction of process. What is not natural, what is natural process. Then also it deals with limitation. It sets limitation. So what does it mean? I'll explain now. So let's talk about the examples that explains direction of process. So let's start with this. See, basically the second law tells that, say you have a 20 degree Celsius room temperature, you keep a ice in a container. After some time, what happens? You get to see it in the form of liquid. Now, the other way around, that is from liquid to ice, it is not possible by itself. That's it. So it sets the direction of the process. But in the same setup, if it was minus 10 degrees Celsius, so we have water, and with time, you get to see that it becomes ice. So water becomes ice. Again, in this case, the other way around is not possible. So these are the two examples that I can think of now. But yeah, so you can imagine when things are natural, when things are not natural. For this to happen, right? For this to happen, you don't need any external force per se. The surrounding is enough. But for the other way around, from the right to the left, you need a external energy, an external source for this to happen. Oh, basically, we need a fridge to convert water to ice. Right? So in our day-to-day life, if we live in a place wherein this is the normal temperature, we need a refrigerator to convert water into ice. So that's the thing about direction. So when you talk about limitation, so limitation is to do with given an engine, right? If we happen to put petrol into it, okay? So how much of it is used as energy? So how much is used as energy and how much will go as waste? How much will go as a waste? So it sets the limitation of efficiency basically. Okay, if this is a fuel source and this is the useful energy we get and this is the wasted energy. So it sets the limitation on the how much useful energy we can drain out of a given source of energy. So it talks about efficiency basically. So it sets a limitation on efficiency. What is the most efficient machine that we can have, that we can build? So once we know the expectation, once we know, okay, till what we can build a machine to be, what is the final goal? Post that, if we try to do it, it's not going to be possible. So setting that limitation is what the second law does. So the second law does two things. One is the direction and another is the limitation. So let's have a look at the write-up. What the first law tells, energy is conserved. So we need a law that talks about the direction of the process and explains natural versus impossible processes. So that's where your second law comes into picture. Direction of nature. So some processes are natural, reverse is impossible, spontaneously. So it also introduces limits. limits on the efficiency of machine, rules out perfect engines. So basically it rules out that you put in fuel and there's no wastage. All of it is converted to fuel. Useful energy is not going to happen. It's set that limitation. So using second law, we'll be able to talk about heat engine, refrigerators, heat pump, and so on and so forth. And everyday phenomena that can be explained with second law is your coffee cooling down in your room temperature scenario, ice melting, or in some cases, water becoming ice, right? Depending on the weather. So all of this is possible with second law. Okay, we make use of two laws, Kelvin, Planck, and okay, I don't want to read it wrong, so I'll leave it. So using these two statements, we'll be able to officially state your second law of thermodynamics. So in the next video, we are going to look at Kelvin's Planck statement and so on and so forth. So that's when we will officially state the second law. Okay, yes. For now, this is just an overview to get a glimpse or an idea about second law.